Welcome to Session 1, Build a Reliable Algebra Workflow. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to classify a mixed algebra problem before performing operations, to separate simplification, solving, and answering into distinct stages, and to verify an exact result using substitution and the requested quantity. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. A disciplined workflow prevents a long problem from becoming one uncontrolled chain of arithmetic. Follow the arrows as decision gates. Classification determines the tool, the requested quantity determines when the work is finished, and verification is a separate step rather than a quick reread. The key distinction is this. Classify a mixed algebra problem before performing operations, then connect it to the second goal. Separate simplification, solving, and answering into distinct stages. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Box the final request and record any units or restrictions. Identify the object being changed and the requested result. Step 2. Classify the structure and name the likely trap before calculating. Use a separate line so signs, units, and restrictions stay visible. Step 3. Simplify one layer at a time, keeping each equal sign justified. Work efficiently without skipping an operation. Step 4. Answer the boxed request and verify through a different representation or substitution. Whenever possible, verify with evidence independent of the original working. Signal 1 is several nested groups. Respond by remembering. Simplify from the innermost group outward. Name the response before calculating. Signal 2 is, the question asks for an expression. In that case, scale known relationships before solving variables. The form tells you which tool fits. Signal 3 is a contextual numerical answer. Remember, check units, domain, and reasonableness. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. Solve for 3 minus 2, 2, plus 1, plus 7 equals 19. Restate the target and identify the most important part of the routine. The first move is, inside the brackets, 3x minus 6 minus 2x minus 2 equals x minus 8. This changes the form without changing the meaning. Next, distribute 4x minus 32 plus 7 equals 19. So 4x minus 25 equals 19. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. Add 25 and divide by 4. 4x equals 44, so x equals 11. State what the transformed line tells you. Complete the argument. Check. 4. 27 minus 24 plus 7 equals 12 plus 7 equals 19. This is part of the solution, not decoration. The final answer is x equals 11. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction, substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. In a multi-minus step equation, what should you identify before calculating? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. F. Focused hint. Read the last sentence and decide exactly what must be reported. Use it to repair your setup rather than guess. An accepted answer is the requested quantity. Explain why it works and name the first step that would expose a common error. The central message is, classify a mixed algebra problem before performing operations. Combine it with a discipline to separate simplification, solving, and answering into distinct stages. Finish by remembering to verify an exact result using substitution and the requested quantity. This turns a calculated result into a justified answer. Reflection. Which stage most often fails? Classifying, simplifying, solving, or verifying? Name one cue that will interrupt that error. Name the error specifically so you can interrupt it next time. Practice one fresh problem within 4 minutes, including a substitution check. Keep the work readable, check it independently, and carry the routine forward.